Okay, we're back with 52 weeks of live coding MLOps. The last couple weeks, what I did was in the first episode, I was able to go through and play around with exporting a model, and I made some progress there using TensorFlow, which is useful. It's actually very important to know how to do anything, and importing a model was a great step. I just really copied some stuff from Colab and exported a model. The next thing that I did was I tried to figure out what was the default way to serve out a model using TensorFlow, using their TensorFlow serve mechanism. Really haven't used that quite a lot. Most of my TensorFlow experience has been with putting things onto a device. I do a lot of device-based MLOps, but I tried it out and did actually get it to successfully serve out a model. But where I left off was I wasn't able to invoke the model endpoint because I couldn't figure out how to do it. So I'm hoping today that's what I can do. I haven't done any prep work for this. It's possible I'll completely fail, but let's go ahead and try. Okay, let's share my screen here. I'm going to make my screen a lot bigger as well, which I had a problem that I noticed before. Okay, so we got this, and the screen is way better here, hopefully. And I'm going to go ahead and go to the serve TensorFlow model example and go back to my CodeSpace. Huge fan of GitHub CodeSpaces. You know what? In fact, what's kind of cool is that GitHub CodeSpace is now available for people in education, and there's some really large instances, in fact. Let me make this a little bit bigger too. So we want to make the screen really big. And I'm going to also use virtual environments, which I don't know why I didn't do that before, but I should set up a virtual environments and put it into my, basically into my path automatically. So if I do this, env, do I have this? Kind of funny, I didn't create a virtual environments. I'll go ahead and create one real quick. So let's go ahead and do this. We'll say virtual environment, and I'll say tilde.venv. There we go. Once I do this, I'm going to go to my bash RC file here, and I'm going to edit it. I can probably go even bigger. Yeah, there we go. Let's make this really big space. And then I'm going to go to bash RC, do the command Shift G, which gets me to the bottom. I like telling my environment to always source a virtual environment, especially if it's a dedicated workspace. So we'll go here and we'll say source venv. We'll do this. We'll say source tilde.venv, then activate. There we go. Perfect. And now if I go through here and I just click plus, there we go. This virtual environment is sourced. I can get rid of the other one. So I can say which Python. Perfect. And then if I go to the make file that I have here, notice I have the pip install set up, and I can go ahead and install tools that they like to give me. Sure, I'll do that. And let's look at the requirements. Notice we have TensorFlow, NumPy, Matplotlib, Pylint requests. It looks like I have some good stuff in here. And let's go ahead and do make install real quick and see what happens. Hopefully it doesn't blow up. While this is installing, does it tell me what version of Python somewhere? I know that they updated Python recently to Python 3.10, which has some major issues with NumPy, which is very annoying. So hopefully I don't run into those same issues, although this CodeSpace is from a while ago. So hopefully it's running an older version of Python and I don't have issues. It is, again, a little bit annoying to have your environments always the latest bleeding edge stuff. I would prefer it to be a little bit behind. So let's type in Python. What do we have? We do have 3.10. Well, so far so good. Got that working. Now let's look at the serve code. Notice the way it works here, which is TensorFlow model server. dash REST API 8501, model name, fashion model. Now, I don't see this model on disk. Where is this? Oh, I see. Because it's in this directory right here, which was this the metadata location here. So if we look at this, we have the saved model. All this is on disk. Here is the model base path, which is right here. So we've got this. We've got this example now. We don't want to call it serve.py either. We want to call it serve.sh. So I'm going to go ahead and grab this out, and I'm going to put it into here because then it makes more sense. And we can do this. We can say user in env bash. That looks a lot better. And we can also do a chmod plus x to make it executable. And then I'm going to remove the other piece of code, which is going to confuse people. I'm going to say get rm serve. Okay, we got that working here. We can do it. There we go. Okay, so I got TensorFlow model server. Let's go ahead and run this. So if I type in serve, it says command not found. TensorFlow model server command not found. Now I may have to do some kind of installation here. So what do I need to do to play around with this? What I can do is take a look at what I did before, which TensorFlow model server. I think I just need to install this, which is like an apt-get install. Is it setup? Here we go, setup. So I just need to run setup. So let's go ahead and do that. I guess I might as well just change this too. I'll do this, say user in env bash, and then we'll do a chmod plus x here, setup. There we go. And so let's run the setup code. Does this get everything working here? Let's just do okay, so this downloads TensorFlow model server. It says denied. So we'll do sudo. Hopefully this works. Okay, so we got this working. Now if I do serve, we got a little bit closer, which is building single TensorFlow model config, model name, and doing something stupid here, which is model name, fashion model, model base path is 1. So expected model, fashion model to have an absolute. Oh, I see. So I need to make the absolute path here, which is fine. And if I say echo $home, just out of curiosity, it doesn't fully give me the path. It's kind of annoying. I like to make things reproducible, but sure, let's go ahead and do this. Workspace server. So let's try that. And we'll do serve. There we go. It says re-adding found under base. Did you forget to name as a number? Oh, I see. So what we need to do, I mean, this is a very weird process, I have to admit. Is it a lot of assumptions here that I think are not good, but there we go. So we got this thing working, and we see, so I just didn't check in my latest changes, which is on me. So it says your application is running. So let me do that now. So I make sure that I don't create a mess. Is I'm going to say get status, make sure that I've got everything here, and I even put something to README that says, okay, setup would be first step would be run. So step 1 would be let's say run /setup.sh, do that, and we'll put a note that says something like this, say, install TensorFlow Serving, and then the next thing is that we want to run serve. So run /serve.sh, and this will serve out model in directory named one. Okay, that looks good so far. And I'm going to go ahead and add this, get status. We should have 3 files, get add, readme. Now, let me also ignore the .vs code, which is annoying. Let's go ahead and add this. I don't want this. So if I say get status, notice I have to add the get ignore now, get add this, get add serve, get add setup sh. There we go. So we've got get ignore, serve, setup, sh, and if I say get status, got it all here. And let's go ahead and commit this, adding working serve. Okay, got this cooking here. It's all checked in. I mean, I guess I could also, maybe add some build steps and all that stuff. But for now, we have serve working. So I'm going to go ahead and run this. I'm going to say basically serve. Awesome. So what do we have here? We see that it's going to run your application on port 8500, and we could even go to the web browser and we can see like a bunch of weird stuff appears. So this is at least a reasonable step, which is I know that it's actually running, but what I don't know is what are the kind of payloads that, like, what does it behave like? I have no idea actually, because I've never used TensorFlow Serving. So I'm going to need to do a little bit of investigation here. So I'm going to look into TensorFlow Serving, and I'm just going to read the documentation to make sure I understand how it works. And so we see TensorFlow Serving is a flexible, high-performance serving system. We've got it running, and it's got out-of-the-box integration for TensorFlow models, but can easily extend to other types of models and data. What can it do? It can serve out multiple models. So that is pretty interesting, or multiple versions. It exposes RPC as well as HTTP. It allows deployment of new models without changing any client code. That's pretty cool. You can do A/B testing, adds minimal latency. That's really cool. So this does look actually very sophisticated. And so one way you could do this as well is you could apparently do Docker, and you can do TensorFlow serving. So that is cool. I did not know that. So let's put a link here about this to our documentation, and we'll say, uh, maybe hits here, say like can deploy serve, can serve model out in 60 seconds. Docker, that's pretty cool. I like this. I'll definitely probably play around with that later, or maybe even today. Aha, here we go. So query the model using the predict API right here. Okay, so that does look pretty cool here. So where's in this one? This one is actually a saved model here. So maybe I need to do this instead temporarily to just get past where I'm stuck, and then I can come back to this. Yeah, let's do that. Let's make things simple here, and I'm gonna stop what I'm doing temporarily to just get anything working. So I think this is a good tip to be aware of, is sometimes when you're stuck, just get anything working. And so what I'm going to do next here is follow the instructions. So I'm going to say Docker pull TensorFlow serving. In fact, why don't I just copy this? Let's just put this into our README and say like, this, put these steps inside of here. We can put this in here. So first up, what I'll do is I'll say Docker pull TensorFlow serving. So we're going to slightly tweak things in that I'm going to use Docker to do TensorFlow serving. And then what I'm going to do is I'm going to get out of this directory temporarily because I don't want to mess it up. And I'm going to say git clone this. I'm going to clone the TensorFlow serving project. And then I'm going to find the demo models. That's what I should have started with. And in this particular scenario, we can go here. This would be the test data. There we go. And if we echo that variable, what do we see? Echo. So test data. $. Okay, so workspace serving TensorFlow test data. So we could even look in there. What's in there? Ooh, all kinds of saved models. So this is promising because it allows me to maybe do that without the container. So now I just do a Docker command here, and I say Docker run on port 8501, and here's where the model is that I care about, and here's the model name. And once I've got that set up, this should actually invoke a serve. So there we go. Are you sure you want to paste these? Yes, I do. Let's go ahead and serve this out. Pretty cool. This running on port 8501. Now all I need to do is just open up another terminal here, and I just need to run this curl command. So if I go ahead and I paste this, it should return out a prediction. Yes, success. So this is exciting. This is the first time I got TensorFlow serving to do a prediction. Now I did use Docker to do it, but this did really give me a lot of tips here on how to work. And in fact, I think this is actually a very interesting concept, which is that maybe it could be a good approach is to use Docker run itself to be the mechanism to deploy pre-trained models, for example, as well, which is something I definitely would like to play around with is to use maybe like a Docker container with running TensorFlow serve, and then go to the TensorFlow hub and just download something and serve it out. But this is definitely pretty promising here. So if I go back to my README file here, we could say like maybe like the next things that we want to investigate. So what's next? So what is next is we need to figure out how to serve out pre-trained models via TensorFlow serve. That's really the next thing that I'm very excited about is because the model I had, I don't really care that much about the initial one. And so I'm gonna actually say Docker yes here, and we can actually I forget the command to do to stop Docker. So let's say like kill Docker kill. I think it's just Docker PS kill or something. Docker kill kill. Let's just say kill all containers. Here we go. Stack Overflow. Stop all containers. There we go. Let's do that. Docker. Oh, this should hopefully stop it. Let's see if that works. And how do will we know it would work? Is if I do the curl. There we go. We know it's not working. So I have a little bit of time. What I'm curious about is, can I do this? Can I figure out how to do pre-trained models via TensorFlow, Serve, and TF Hub? That's really what I'm excited to try to figure out. And so how would I do this? So let's keep reading. So end-to-end server and training tutorial. That looks interesting. I'll maybe come back to it. So the easiest way is to use Docker image, which I did find out. That's pretty good. They don't recommend not using Docker, which makes sense now that I've tried it without Docker. So configure and use TensorFlow Serving, follow tutorial using TensorFlow Serving models, configure a server to make it serve your use case, extend it, create a new type of server. Okay, so I think then I need to just read this, follow tutorial on serving TensorFlow models. So let's see a tutorial. So this tutorial shows you how to TensorFlow serve components to export a trained model and use a standard model to serve it. This uses a softmax regression model for MNIST, which is actually what I was just using, MNIST fashion data. So what do we do? Train and export a model. So this kind of goes through here and it shows basically how to do that, which I've done before. Okay, session is the TensorFlow session. Tags is a set of tags. Oh, I see. This is interesting though. So maybe I do need this. Let's take a look at this. So train and export a simple model. Okay, well, let's try it out. Let's see if I copy this code here and check it in, if this will actually give us everything we need. So I'm going to go back here and I'm going to call this thing. What do I call this thing? They call it MNIST saved model. Okay, let's do that. Let's say touch MNIST saved model.py. And let's go in here. Let's paste this in. So what do we got here? We have TensorFlow, import MNIST. Let's try it out. So if I just say Python MNIST save model, what happens? It's almost, it appears to be doing something. So it says, okay, we don't have GPUs, which we know about. No module named MNIST input data. Well, let's add this to our requirements. So we'll say make install. Add this in. Well, that's interesting. So we need to figure out how to actually install that. Clear it. So what this says, well, let's do this. So I think the key takeaways, which again is this is the inputs, this is the outputs, this is really where I was lacking. I guess I could just try this. Let's try it out. Maybe this will work. So I will CD up here. Oh, we already have serving. So that's pretty cool. So we already have serving here. Let's go here, CD into serving. And what does it say to do? It says CD into there, which is what we did. Delete this if it already exists, which I don't think it does. RM that. Next up, let's train the model. This is where I'm curious if it works. Okay, let's see. So this is a pretty big Docker image. And this might be why having a very, very powerful machine would potentially make sense. And I do have access to really powerful machines, even on GitHub CodeSpaces. I just didn't happen to use it today, but I would probably use it in the future. Let's keep going here, extracting this. Forwarded ports, warnings. Whew, boy, 1.6 gigs is quite big. All right, still going here. Boy, definitely taking quite a while to run this. So what it's doing is we're doing this step, which is training the model, and hopefully it will train it and export it. So now hopefully it trains it. Okay, extracting. We can even look, there we go. So now it's downloading the newest Docker container. It's running this and it's saving the model. Excellent. And there's where it's saved it. Look, see, it saved it as temp MNIST. If we go through here and we look at this, temp MNIST, it put it into that directory. So that's pretty cool. And then we can see that in fact, this even has the variables. It has, and this is the serialized TensorFlow save model. This is the graph definition and the metadata. The variables are the serialized variable of the graph. So we can load the exported model with TensorFlow model server. So we can do that next. Let's do that. And there we go. That's running. That's a good sign. And now we can test the server by doing some kind of load testing, and we should basically, make an inference error rate, which is pretty cool. So if I go over here, I can run that test, and I need to change into serving, and then here we go, pulling Docker image, going through, and it's doing all kinds of invocations. Pretty cool. So we have this endpoint working, and then I'm able to actually run that. So I would have to look at this, the MNIST client code, which TensorFlow serving example, we would have to go through here. TensorFlow serving example, MNIST client, which would be this piece of code. And this is actually what goes through and does all of the different inference tests here. So, definitely gotten a little bit further down the road here. I think next steps for next week would be to, well, first of all, I'm going to stop this here. So I'll do that same Docker command. I'll do history, and let's just run Docker command that kills all of our instances here, where is its history? So we want to run pound 37, kill all of our Docker instances. So basically next week, what I will do is I'm going to figure this out. I'm going to figure out how to download pre-trained models and serve them out via TensorFlow. I did get very far down the road here with serving out TensorFlow, and that was pretty exciting. All right. I will see everybody next week.